Okay, this appears to be a Haarp downburst over northeastern Oklahoma on September 18th, 2014. Right at daybreak, we have some thunderstorms that suddenly go into this breakdown outflow. In fact, let's look at it right at daybreak, and we can see that it's pretty huge amount of energy was released. Okay, so the downburst actually happened right here in the corner, according to the vertical velocity satellite map. So let's just step through, and it's just spilling out, and right at this point here we have this round, a circular boundary here that's demarcated by basically a little band of dry air. That's the mark of the Haarp downburst. Let me step ahead a little bit and let it run. Whoops. Zoom here. Okay, so and there's several, there's an economic goal here happening, and there's also quite a bit of proof that this is a Haarp downburst. If we jump ahead again, we can see typical of the Haarp downburst is that okay, they heat the ionosphere 90 miles up. It expands and presses dry air down into the jet stream, which then presses the tops of these storms and dries them out. And as it hits the more dense layers of the atmosphere, it begins a roll cloud. In other words, it's rolling at the edge, and we can see that here in the here's the water vapor map, and we can actually, whoops, I'm going backwards. We can actually see this dry air roll cloud right here. And what's powerful proof that it's not a normal thunderstorm collapse cold front, outflow boundary or gust front, is that it has concentric rings inside of it. In other words, they did a Haarp downburst. A minute or two later, they did another one. Each one of those produces the dry ring, this roll cloud of dry air. Let me stop this so we can look at it closer. Okay, right here we can see two rings, kind of concentric. I want to zoom just a little. And here even better. Okay, that starts over. Now if we jump ahead a couple hours, you can see this. And it continues moving outward. Let me stop this and we'll go through real quick. And I've got a NexRad map that's just dynamite to show this. Because after they did this downburst at 7 a.m. right here, there was still some storminess up here, and they hit it again, and it showed up in the NexRad just crystal clear. Oh my gosh. Okay, so here we can actually see one, two. I see three rings right here. A dry air roll cloud. And that's proof of the Haarp downburst. Okay, so let me, there's one more water vapor map here. This is a couple hours later. Okay, so this thing progresses outward at a steady rate. It maintains its round shape. It maintains that dry air core as it's rolling across the lower atmosphere. And the storms that are being pressed down by the dry air, they dry up. Let me show you this NexRad. Because after all this is winding down, what happens? Why, they Haarp downbursted again. Okay, now this is early, and oh my gosh, look at this ring, folks. Now this is an early map, just after daybreak. Oh my gosh, we can see these concentric rings. That is beautiful, folks. But this is not even the best evidence. Okay, that rolls across. These storms just disappear because they're being pressed by dry air on the top. Now later we get this. Let me move over and zoom in. In fact, let's get the overview first. Okay, this is just maybe 2 or 3 hours later. This roll cloud is still persisting out here. That's something that a thunderstorm outflow boundary never does. I mean, it goes out 30, 40 miles and it just poof, it's gone, because it doesn't have the spinning momentum that a smoke ring has to hold itself together like the Haarp smoke ring of dry air, the roll cloud. So here we have the storm's trying to reform, and they hit it again. And what we see here is some concentric rings right here. Right here, this little pop right here, and boom, right there, concentric rings. They look like tree rings. So anybody want to try and explain that little radar artifact there? Let me show you the smoking gun evidence, and this is the vertical velocity map. And here we go. This is vertical velocity at 5,000 feet altitude, right at the time this was happening, right at 7 a.m. This gray right here means falling air, and it's right in the right spot, and we go to 10,000 feet, we see the same thing. Dry air falling right at that spot. So the next question would be, could it be just natural pressure at the surface doing that? Here's the sea level pressure. This is just the pressure at the surface. And the thing is, this is 7 a.m., so this is about the time that this was happening. And we can see there is just a little hint of high pressure right here at the surface, because these barbs point into the prevailing wind, so we actually have a little bit of clockwise rotation here. So this map is saying that there is some high pressure here at the surface, but I'm contending that is the actual Haarp downburst in progress. And the jet stream is homogeneous. There's no high pressure here. All these isobars are equally spaced, and the jet stream is going to, if a storm develops, it's going to push it east-southeast. Let me show you my theory as to why this was done. Okay, 3 days ago, Hurricane Odile, or Odile, was about to go into California. So the Baja transmitter hit it on the west side, causing it to turn right. And it has actually turned right and actually drenched this cotton growing area. Let me explain this map here. This is the percent of harvested cropland in cotton. So the more green it is, the more cotton was grown there. So solid green is more than 50% cotton. So what we see here is Hurricane Odile was driven over this cotton-rich area, and now the jet stream has caught it and dragged it right on top of the Texas Panhandle, which is the largest contiguous cotton-growing area in the world. Roughly a third of the world's cotton comes from right here. And cotton cannot tolerate heavy rain in September without being damaged. The crop will be damaged, the yield will be damaged, the quality is damaged. So, to my mind, a possibility for why they would stop a thunderstorm here that would then go down over this cotton growing area would be that perhaps someone has some either cotton ownership or corporate cotton farms or cotton futures that they can cash in on this cotton here at the expense of the Texas Panhandle cotton and the Arizona cotton. That would explain these two Haarp actions, that there is a agricultural futures payoff here of millions of dollars. And what's certain is that this big cotton crop here had been doing quite well, really well, and now it's really up in the air as to how much damage there's going to be, how much yield has been reduced. But the quality is just destroyed when it gets a lot of splashing mud and soaking rain. So that is a possible economic motivation for these two Haarp attacks. And again, these storms would have been carried straight down over that cotton growing area. Last thing I wanted to show is that these Haarp actions are actually incorporated into the forecast maps. So here it is, 5 a.m. This is before that thunderstorm was downbursted. We don't see any storm here. Now we go 8 a.m. This is at the time that the downburst was happening. So they actually have the sense to not predict any rain right here because they know the rain's not going to happen. And they also have this storm die out and disappear. So here is 11 a.m. and by, oh gosh, they jumped ahead. Now it's 8 p.m. So they skipped way ahead there. So that's odd. But anyway, this rain here is not happening. And okay, full day and a half, couple days ahead, still no rain there. But the Texas Panhandle is continuing to get this record-breaking September flooding, which is just going to devastate the cotton out in the Panhandle. So, oh, and one last thing we can watch is the radar map as this was happening. You can see here's the downburst actually happening. Boom. Squeezes out the rain. It kills the rain in the center, and the rain is squeezed out to the side. And then later we have this. And finally, basically the rain is stopped. And that's pretty typical of a Haarp downburst. So that's what happened September 18th, 2014. We have two coordinated Haarp attacks, and basically it has done a great deal of damage to the cotton in Arizona and Texas, whereas it looks like it's going to help the cotton in Missouri, Alabama, Georgia, Florida, South Carolina. So exactly why this is happening, that's about as good a guess as I can come up with right now. But I feel quite certain that that was a Haarp downburst, despite a very minor amount of high pressure at the surface. But I believe that high pressure at the surface was actually a result of the the downburst itself. But to have the vertical velocity map show the falling column of air from 5,000 to 10,000 feet, that's just really powerful evidence. And this is right in the core of those thunderstorms. That's not natural. It's not natural. Okay, that was your Haarp activity for Central U.S. September 18th, 2014. Thanks for watching.